When preparing a series on the history of AI for games, we're bound to disagree on which titles to put in the spotlight. But for this episode, we were all in agreement, given this is a game we couldn't possibly ignore.
If you were to jump on the web and search for top 10 best video game AI, there's bound to be some familiar faces. You'll find classics like StarCraft or Halo, perhaps some beloved stealth games like Splinter Cell or The Last of Us, plus some highlights of other genres, like Forza Horizon, The Sims, or Alien Isolation. But there's one game you can guarantee will appear in that list every time. F.E.A.R, which is an abbreviation of First Encounter Assault Recon, is a first-person shooter released on PC and consoles back in 2005 by Monolith. And despite being over 15 years old, it's still heralded as one of the best examples of AI for combat action games. And the secret to making it work is a mixture of AI innovations and a lot of clever game design, as it so often is.
F.E.A.R is the first game to use an AI technique called automatic planning. It's heavily inspired by a system called Strips from 1971, which was originally designed to program robots. The game allows characters to plan out their strategy at a very high level, where they're going to cover, whether they shoot at the player or throw a grenade. In planning, this means giving each character goals they want to satisfy. But in order for those goals to be achieved, you need to model all the possible action the character can do in the world.
Each action has what are known as preconditions, which are the facts in the world that have to be true for it to happen, and effects, which are what happens when the action is executed. So if you see a character run over to an object and knock it down as cover, it's because it planned out the movement, the knocking over of the object and going into cover, as three actions where all the preconditions and effects could line up. It cannot knock over an object that's already knocked over, or run to an object it can't reach, because the preconditions of the actions told the AI it's just not possible.
Once it comes up with a plan of attack, it then uses a final state machine, much like Half-Life did, to put all the action together. One of the clever things that Monolith figured out is every action an AI makes in a game is a form of animation, be it standing firing a gun, moving to another location, or interacting with an object. So all the planned action are translated into three states: moving to positions, animating, or special animation with what are known as smart objects.
What's crazy is that they use the same AI for nearly every character in the game. The soldiers, the ninjas, even the rats use the planning AI, except all they plan for is how to run away from you. The only character that doesn't use it is Alma, the creepy little girl from the story, because she's not designed for combat.
But the thing that F.E.A.R also does really well is that the developers knew when to use AI to achieve the intelligence they wanted, and when to just cover it up with clever hacks and tweaks. Like, not two soldiers in F.E.A.R know each other exist, but they look like they work together.
So one character will fire at the player from cover, while another will move to a location to the side of you. When those things happen together, it looks like a flanking maneuver. The real trick that helps sell this illusion is that the game makes the NPCs shout lines of dialogue to tell each other what to do, even though they can't hear the dialogue or respond to it.
Planning has been used in a variety of game scenes, with the AI of F.E.A.R inspiring the modern Tomb Raider games, Total War, Just Cause, and Deus Ex. But this also led to the introduction of another planning approach called Hierarchical Task Networks. What has been used in games like Dying Light and Horizon Zero Dawn, HTN is a little bit more designer-friendly, because you can not only design the actions, but which action group together in ways that make sense.
It means the planner spends less time figuring out combinations that are obvious to players, and builds more meaningful tactical gameplay.
Planning has had a transformative impact on the AI for video games, but how many other techniques are out there that could be used to create even better games? At modl.ai, that's what we're trying to figure out, so stick around to hear more from us on the history and future of AI for games.